My name is Yujian Tang. Right now, I'm a developer advocate at Zilliz. I'm actually drinking coffee with milk right now, but when I go to coffee shops, my favorite thing to order is 2 shots of espresso with sparkling water over ice and a little bit of cream.
What?
Caramel shots. Yeah, usually caramel shot.
2 shots of espresso over ice with sparkling water?
Yeah,
You
with
pour the sparkling water in the coffee?
Yeah. It's actually
like
it's
a
really
soda
good.
coffee?
Yeah, it's really good. If you put a little bit of caramel syrup and some cream or milk in there, it's
Oh my god. There's not a special name for that?
I don't know if there's a special name for it, but this is what I've been ordering for the last. I saw it at this place called Espresso Vivace or something like that in Seattle, and then I haven't seen it at the other places, but I go and usually if I order it, they'll have it. I don't think Starbucks does it, but some places, some mini locally owned coffee shops here in Seattle, they have sparkling water, and so they'll make it for you.
Hello everyone. Welcome back to the MLOps Community Podcast. I am your host, Dimitrios, and today I'm flying solo again. Y'all are probably thinking that people are starting to not like me, or I must not have any friends, because I've been doing a few of these solo podcasts recently, and it is not true. I'm just going to refute it right now. I do have friends and I could ask them, but I've actually been liking doing this solo thing. I am going to be straight with you right now, because I always would have co-hosts come on, because I was always insecure that I was not able to go sufficiently deep enough in my questioning to actually provide value to you, the listener. However, now I tried it and I feel like I was all right. I feel like I could go deep, and I know a few things now. I mean, let's be honest, it's been 3 years. I've been doing these at least twice a week for the last 3 years. So hopefully I picked up something along the way. But as always, if you have strong thoughts on if I should be having co-hosts come so they can go even deeper than I'm able to go, please let me know in the comments or in the reviews or all that fun stuff. I love hearing from you all. It is a pleasure being able to do this. I have the most fun interviewing all of these great minds. And speaking of great minds, let's talk about our guest today, Yujian Tang, who currently is a developer advocate at Zilliz. Zilliz, you probably know because vector databases are blowing up. They're exploding on the scene right now. And Zilliz is the parent company that keeps Milvus in check. Milvus is one of the OG databases, vector databases out there, and they are built for scale. They are absolutely just beasts. You've got some really big companies that are using them, and these companies, they got scale. All right, so let's talk about that. Now, in our conversation today, we talked about vector databases. We talked about the democratization of AI in this LLM world and how vector databases play in that. And we also mentioned all different kinds of ideas around the best ways to fully utilize your vector database if you are using it in conjunction with a good old large language model. Now, there is some very hot topics like chunking and dense vector representations, sparse vector representations. And so we go into that a little bit, and we also just talk about Zilliz and what they've been doing and how they have now Milvus Lite, and since we are releasing this today, there's also Zilliz Cloud. So there's easy ways for you to get up and running with a vector database, and if you want to choose Zilliz or Milvus, it is very easy. And I got to give them a shout out because they were kind enough to sponsor this episode, and because they are sponsoring this episode, we are able to continue to bring you some absolutely amazing content in the MLOps community. It helps us a ton for them to be sponsors, because we get to do stuff like have meetups all around the world, even if meetup.com is costing me an arm and a leg. Seriously, if anybody knows any better alternative to meetup.com, please tell me. I've tried Luma, but you don't get the whole notify people when you have an event. I mean, meetup.com, seriously, How do you sleep at night? That's what I want to know. How do you sleep at night? Oh my God. Anyway, let's get into this conversation about vector databases before I fully derail it by talking about meetup.com. Anyway, if you can just share this episode with one friend who you think would enjoy it. All right, let's get into it. Oh man, what is this? You tried 100 different snacks in the last 2 years?
So
wait, what are we talking? Snacks like chips or like guacamole? Is that a snack? Hummus?
like single packaged like goods that are like packaged for like single person like consumption, kind of like Justin's like peanut butter cups. Yeah, like those things, or like the Koia Koia, I don't even know how to pronounce it, like the drinks, or like
energy balls.
Yeah. Or like there's like these like coca truffles that have some sort of coca lavender honey stuff in them. They're like pretty.
Oh my God.
Yeah,
that sounds amazing.
Yeah, they're actually they're okay. Did
you record on TikTok your response too? So you remember?
I just recording me eating these. I have it on an account somewhere. I just got too lazy to continue doing it, because I was like, okay, like I just can't be on so many social media platforms. And I got a new phone. I don't have TikTok on my new phone, because I was like, all right, I don't want to be on TikTok, so I'm just gonna get rid of it.
Yeah, it can definitely take up a lot of your time. So you're working at Zilliz right now. You're a developer advocate. I mean, you've been doing all kinds of cool stuff with vector databases. Tell me a little bit more about your trajectory and how you got here.
Yeah, I guess I can just start kind of at the beginning. Or after I graduated college, I was working at Amazon for a while. I worked on the AutoML team, so I built like the infrastructure side for machine learning models, and then I left Amazon to kind of start working in startups. I started a couple of my own like companies. The first one that I started, I like created this app. It was like around like some sort of like data aggregational kind of stuff. I got a few thousand users on it, but I never really figured out how to monetize it. So I shut it down, and that was when I started working in startups. And I've bounced to a couple different startups, kind of doing this kind of developer advocate kind of stuff. This is my first role as like an official developer advocate. Before, it was like full stack engineer or some stuff like that, and then or like technical consultant or something like that. Basically, like I decided at one point that I kind of enjoyed this kind of content creation stuff, and I started like writing my own blogs. So last year I wrote a blog that got like 200-some thousand views last year.
Nice.
And then someone reached out to me as I was like shutting down like my second company, because I was like, okay, I figured out how to monetize this one, but no like product market fit. So you're not really making like a few $100s a month. So I was like, all right, I can go do something else.
Yeah, that's hard.
And then they were like, hey, there's this company who's working in this really cool space, and I looked into vector databases because I'd heard about vector databases before, but I never really knew a lot about it. And then as I poked into it, I was like, oh, this is like something that I think really has a lot of potential to be like an integral part of stacks, especially for the large language model applications. And then kind of just seeing like the other applications of it. For anything that requires semantic similarity, it's just like a very easy way to kind of be searching through those documents and stuff. And so I was like, this would be a really cool experience. And I met the team, and I was like, wow, these people are all really smart. And then they were showing me the architecture, and I was like taking a look at this. I was like, oh, this is like super cool. And so I was really excited to just kind of like get on board, and here we are.
And those two companies that you started, the first one was around data aggregation. Was the other one around data in some way too?
It was a natural language processing API. So it was like a text-based like processing API. So I was already like in the space of doing like this kind of like text-based kind of like stuff with like natural language processing. And so it made a lot of sense to me when like vector databases were explained in the context of semantic search.
Mm-hmm. Yeah, you had been stewing in it for the past couple of years and probably felt a bit of the pain that vector databases can solve and solve for. Yeah. So let's talk about that a little bit. For the uninitiated, vector databases have blown up in the past, I would say 6 months, basically since ChatGPT came on the scene. They've been the unsung hero of this whole generative AI wave. why is that?
I really think that, like prior to this, it's not like vector databases weren't being used. They were being used for some of the more traditional use cases, like the semantic search stuff or like image search or product recommendations. But kind of the wave of LLMs has really brought up vector databases into more of a mainstream kind of topic, I guess. And the real reason I think for that is just because there's so many data problems with LLMs. LLMs are, so we'll take GPT-3 or 3.5, whatever, for example, right? It's only trained up until a certain time. So it's only trained until September of 2021. So if you, in 2023, you want to be using an LLM app and your backend is like GPT-3 or 3.5 or something like that, you're only getting access to data that is almost like a year and a half out of date now. And the only way that you can kind of the only way you can work with these with modern data is that you inject the data. And the other thing is for like enterprises, they want data they want to be able to interact with their data. And so they need some way to do that. Basically, you need some way to inject this data layer. And that's really where vector databases have been really popular, is that they allow you to inject the up-to-date data, inject your domain data, and if you're interacting with ChatGPT or GPT, whatever, a lot, LLMs a lot, it's going to be costly. And there's going to be some things that are FAQ kind of stuff, especially if you're working on like a large system. Let's say you're at a call center, you're going to have customers who are going to be asking some of the same questions. And so if you have some sort of chat bot and a lot of customers are asking the same question, you're going to want to cache some of those queries so that you can return back your answers without having to ping the LLM again. So these are like the three main use cases that I see vector databases being used in for LLMs. And I think that's why they become super popular, is just because if you're building an LLM app at scale, there's almost no way that you're not using a vector database.
Yep. Yeah. And this is something fascinating that I think about a lot, that trade-off of when you use a vector database and when you just try to stuff everything into the prompt, and how you look at that. Because I know that Anthropic's context has, you're able to throw so much more into the prompt. And you just raised a great issue, is that, hey, it's not only the stuff that you're putting into the LLM that you're grabbing from the vector database, but also when it comes out of it, you can go and save it in there and cache it in there for the next time that you ask that same question.
Right.
But how do you see that? Because I think that's something that is coming up more and more. Okay, where's the role of the vector database if we can just put millions and millions of documents into a prompt eventually?
Yeah, that's a good question. But I think the main thing there is, do you really want to be expending 100,000 tokens every time you talk to Anthropic or every time you talk to Claude? I don't know. I think it's can you do that? Yes, but I think it's a cost issue. And for this, LLMs, vector databases help solve part of that issue. But what you really need also are other tools or frameworks around it. Some of these AI like agent building frameworks like AutoGPT or Llama Index or LangChain are really offering some tooling around that to make sure that your prompts are reasonable, or that you're only sending like the right amount of info to your prompt. So I was working with LangChain recently, and LangChain has this thing where they limit the number of tokens that you send to the prompt to kind of keep your costs down. But I think that my main kind of thought around that is just, you probably don't want to be using 100,000 tokens every time you talk to Claude, or you're going to only talk to it like 3 times a month, right?
Yeah. You're going to have a damn good reason for talking to Claude if you're going to be doing that. Yeah, it makes complete sense. It does seem like costs can skyrocket if you are hitting that limit continuously. And
right.
So there is something interesting too that you were mentioning before, is how it's almost like you have these large language models. And we talked with Niels at Cohere a while back, and he was mentioning how difficult it is if you want to make a large language model understand something from the present, like someone died.
Yeah.
And you have to show them so many different examples of this person dying to update the knowledge that a large language model has every time the world around us changes. And it feels like that's why vector databases can be slapped on top, and you can say, all right, cool, and let's look at what we have in the vector database first, and then we can go and query the large language model. And one area that I'd love to explore with you, and I'd love to hear what you've been seeing, is these newer models that are coming out that have been open sourced, and they're smaller.
Okay.
It feels like you can lean on a vector database a lot more than we originally thought.
Mm-hmm.
Have you been seeing that, or how have you been like noticing the performance? And as opposed to, I mean, obviously GPT-4 is a beast in its own, and it does its own thing, and it's very hard to find something in the open source world right now that is as good as GPT-4, right?
Yep.
But I feel like what is going to start happening more and more is this idea of, hey, smaller models leaning on vector databases more, and we're not asking it these crazy complex things. We're just asking it these things that we know it can do.
Right. Yeah, I think that at the heart of machine learning models in general, and like why is it so hard to retrain one of these models, why do you have to show so many examples, is that large language models are still neural nets. They're all statistical models, right? They're all using some sort of, they're initialized with some sort of weights. They're given this data, and the data really, this is why they call them training neural networks, right? It like adapts to the data. And so when a neural network, for example, I think the point that you brought up about having to show a lot of examples of the queen is dead is like a interesting point, because we as humans, like we hear, oh, the Queen of England, like she's passed. We kind of immediately are like, okay, she's gone. I think that's because, I guess this is a bit more philosophical, but like humans kind of have this like inherent built-in maybe feeling or knowledge of like time and like death. And machine learning models don't really, I don't think they fully grasp the human mortality.
Yeah.
And so we as humans, we hear that and we're like, okay, that's fine. But you tell the language model, and it's a statistical model. So it says, well, based on my data, here's 3 million points to say the queen is alive, and here's one that says the queen is dead. So I think the queen is alive. And like the whole like fine tuning thing, this is the problem with fine tuning, is if something like that is a major update, or if Microsoft buys OpenAI or some like major update like that, it's going to need a lot of examples. And that's why the whole like vector database thing is interesting, right? It's like why you can have this kind of like data cache, data store that just sits in between the user and the LLM. And really what you use the LLM for is just understanding what the user is saying, to parse the question, and to reformat the query or reformat the response in a way that makes sense to the user in like a conversational kind of like sense, right? You want it to be like a chatbot. So I wouldn't be surprised if really what we end up seeing as like the LLM stack is just that we'll have some sort of framework that it's like very easy to switch out these language models. Because is ChatGPT 3 a lot better than ChatGPT 2? Yes. Is ChatGPT 4 a lot better than ChatGPT 3? Yes. But is it something that we can really tell the difference of when it comes to most like enterprise use cases? I don't think so. I think that like if you have a chatbot that you want to just chat naturally with, maybe ChatGPT 4 outperforms ChatGPT 3 by a lot. But in terms of like, for like most enterprise scale use cases, what are people going to be doing? They're going to be asking questions about some of the data. They just want it to be able to formulate some sort of chatbot type response that makes sense, like full sentences, paragraphs, and 3.5 and 3 can really do this. And Vicuna can do this, and like Llama can do this. And I think most of the open source models have reached the point where if you get them right, if you use them correctly, they do pretty much match like 3 or 3.5. And there's been a lot of research papers around this. But one thing to say here is that also it is difficult to judge how good a large language model is, because only have, there's no quantitative like metrics for it. It's all qualitative. It's all, oh, I'm reading this sentence here. Does this make sense to me? Like that's pretty much all there is to it. So I think that like I think that there will be more like small language models, but it is interesting to see there's a lot of this new like language model development. And I really do think that having a vector database and the LLM stack is going to be pretty integral. Like anybody who's kind of building this stuff into the future is probably going to be using some sort of vector store.
Well, so break down how that works. What does it actually look like in practice when you're using a vector store? You mentioned how, because my understanding is that you can actually you break down how it works. I don't want to even tell you what my understanding is.
Okay. So let's say, I'll just cover like the architecture of OSS chat, which is like one of our like demo apps that we use that lets you chat with open source documents. So basically what you do is if you want to build one of these apps is you go and you grab all the documents that you need, and then you pipe the documents you need, and you pipe them into a vector database in this interesting manner. So you break them down and chunk them, obviously. And what you do is you actually send the documents to ChatGPT or Kuna or Llama or whatever, Bard, whatever open source, whatever LLM you want. And what you do is you tell the LLM, like, here's some documentation. What are some questions that I could ask about it? Or something like that. That might not be the exact prompt, but it would be something like that. So now you have the question space and you have the answer space. And what you do is you store both of these in together. And so each entry into their vector database is going to include a question and an answer. And now you have a way to query for the questions instead of saying, okay, so if I'm a user and I only have the docs and I want to say something like, can you show me how, I don't know, XYZ, how does Torch Vision work? And I want to ask PyTorch about it. It's going to be very difficult for it. So maybe I want to say, how do I build a CNN with Torch Vision using XYZ modules? It's going to be very hard for the vector representation of just the answers to give you a good response. So you have to store the question space as well as the answer space. And so first, once these documents are sent to ChatGPT and it generates these questions, these entries are put into the vector database that includes the embeddings for the questions and the answers. And then when the user comes, the user says, I have this question, show me how I can build a convolutional neural network with PyTorch. Then what it does is it says, okay, well, out of these questions, which one of these questions was generated from which one of these documents generated a question that responds to this? And it finds like the closest question, and then it says, okay, well, here's this tutorial on how you can generate a convolutional neural network, and then it outputs all the code for you. So the thing is that you have to kind of store both the question and the answer space, and you just use it as you use the vector store as your first place to go query. So one of the things that you'll also see is if you ask a question about PyTorch, let's say we're talking, so the way OSS chat works is it can predict which open source library you're asking about. But if you only have PyTorch documents and you ask a question about, I don't know, Hugging Face or whatever, it's not going to be able to give you a correct response, and it'll default back to ChatGPT and it'll see what it says. But most of the time, that's up to you as like a user in your production use case, whether or not you want to default back to the LLM or if you just want to say, we don't have that information in our data.
Yeah. So one of these use cases that you mentioned before with the enterprise, and I think it's becoming more and more popular, is the idea of we have a knowledge base and we have everything in a million different places, but we can pipe all of that into a vector database, and we can have it on hand so that if people want to query different questions about how this project is going or how this product was created or who was involved with it, et cetera, that can happen. And the way I understand it is you pipe all of that data from all these disparate sources into the vector database, and then you're chunking it out, you're sending it to your large language model of choice, asking for the questions that can be asked around that. You throw that back into the vector database. But at some point, and if I understand correctly, you also are going to get these questions that haven't been asked. So then let's say there's a question that I want to know, was John working on this project when Henry was not on the team yet, right? And that seems potentially it doesn't need large language models to do, especially because they could hallucinate that really easily and just tell you whatever. So how have you been seeing those kind of situations where I have a question, a very specific question, I go into the vector database, the question hasn't been asked yet, and then what do you do from there? And then how do you like maintain the validity of those answers?
Yeah. So the vector database you don't actually have to store questions that have been asked. You actually ask ChatGPT or whatever LLM you have to come up with a set of questions. And so I think that in that case, perhaps the LLM has not come up with a question, was John working on this project before Henry had joined the team? But, once you have one of the things about, well, I can only say that Milvus has this. I don't know other databases that well, so I can't say exactly what they have or what they don't have, but Milvus does allow you to do this kind of metadata search around, okay, let's say we have a filter and you want to say, I only want information about this project from these dates. Then you can pass that in, and then it would be up to whether or not the LLM can parse that correctly. And that's something that is kind of, that is like a more up to the user's implementation and how the user is able to implement that, on whether or not that is able to be answered easily, or whether or not you're going to get some sort of more generic response. But I would say that like you would just have to think about some of the filters that you may need to apply on your data and allow the LLM to kind of like know this kind of stuff. It is very unlikely that you would see so like, for example, with that question exactly, it's very unlikely that you would see something like, this was done when Henry had not yet joined the team. But it's possible that you see something maybe in the docs, and maybe this means you don't have to do the filtering, that maybe if you have something in the documentation that's team members who worked on this project were John, Barbara, Sam, I don't know. And then what the language model could understand from that is to query these documents and look for ones where Henry is not mentioned in the team name. But yes, I mean, like that's a tough question, right? That's like something where if you are building the LLM app, that's kind of up to you to decide how you want to handle these things, where the user may ask a question that the LLM doesn't know how to parse and that hasn't been asked.
Yeah, I get it. And I guess the other big question for me always, it comes back to how can we set up some kind of process or rules or whatever to where we don't need to use the large language model unless we absolutely need to? Because I think it's always going to be a better scenario if we don't, considering that it can go off the rails, or if we can get the information just directly from the database, it's going to be faster and cheaper and all of that. So like, how can you set up those, potentially just those rules? I imagine it's not going to be hard coded. Maybe there's actually people, there's researchers out there that are creating papers on this very topic, but I wonder about that a ton.
How to set up rules around using vector databases and like an LLM app as okay.
Yeah, I mean, it's really like how to make sure that you don't overuse the LLMs because you don't always need them, right?
Yeah. I mean, I think that, well, the way I kind of see that working is just then you would say, okay, we only want, if we want you to query the vector database first, and if the answer is not within a certain distance. And so, okay, this is where we get into like vector embeddings, right? So vector embeddings are these numerical representations of some sort of data, and they're usually taken from the second to last layer of your model. And one of the things that the way that vectors are indexed is based on what the vector embedding actually is. And then there's multiple ways to measure distance, but the two ways that we do it are inner product, which is basically cosine similarity, or L2 norm, which is the L2 norm of two vectors. I would say you would basically say, here's a query. Are you finding anything within a certain you say to the vector database, are you finding something within a certain distance of this? And that distance metric is a parameter for the user to tune, for the user to understand, like, what makes two queries too far apart. Because what you normally do with this is you say, give me the top 3 results, or give me the top 5 results, or give me the top whatever results. And then you look at those results and you say, these results are, like, this result is the right one. And maybe it's the second result that's returned, maybe it's the first one. Usually we just assume the first result, the closest one, is going to be the right one. But if you have like certain things where you want to say, because the vector database is never going to not find a solution as long as there is a vector in the vector database.
Hey, Laszlo here. If you're serious about MLOps, you hit subscribe right now.
If there's only one vector, it will return that vector every time. You have to set some like parameter that says, if the vector is this far away, then it doesn't count. Then it's not close enough to our query vector. And that is actually up to how well you know the data.
What do you mean by that? How well you know the data?
So if you want to say there's a certain vector distance that is too far from the vector query, you can kind of like look at some of the distances between your vectors and understand, okay, these two vectors are, let's say, 1,000 units apart, and that is too far to be related, because maybe one of them is like apples are pollinated by birch trees in the Pacific Northwest, and the other one is like Kobe beef is raised in Japan. Or maybe the other one's...
You just came up with this off the top of your head? That was incredible. I love the creativity there.
Oh, thanks. Yeah, I mean, these are
about food though, so they are kind of similar.
Yeah, that's why I was saying, okay, maybe the second one should be something like
Northern California is better than Southern California.
Yeah, so maybe the other one should be something like the derivative of E of X is always E of X. Okay,
there you go.
You have two completely unrelated topics, and you say, this is where I draw the line. But you could also draw the line at the food one. You say one is about beef, one is about apples. These are two unrelated. To say that this is a correct result.
As a vegetarian,
you have to kind of know what your data looks like and know like how far apart is too unrelated for you as the querier.
Yeah, I see. So as the querier, you're the one, and correct me if I'm wrong, you're the one that is setting up these rules on what it returns. If it is not far, or if it's too far, then you're going to say, don't return that, because it doesn't make any sense.
Right. Well, I guess it might not necessarily be the person who's running the queries who sets that up. It's probably the person who's setting up the app. And I'm just assuming that these are the two of the same people, but that's not always the case. In fact, I guess that's usually not the case. But the person who's setting up the app should understand that at a very basic level.
Yeah. Okay. And so then when it is too far, that's when you say go to the large language model. Highly oversimplifying this, aren't I?
I mean, yes, but yeah, that's basically what it is. If it's too far, you say go to language model, or you say return like we don't know.
I see. All right. So one thing that I was thinking about too, as you were mentioning all of this good stuff, is how the vector databases, like, they're great for certain use cases, as we've been mentioning, but they also are maybe not great for other use cases. And so when would you advise someone not to use a vector database?
Yeah, I think that if you have something where your primary differentiator is something that can be stored in like key value pairs, then you don't need a vector database. And in fact, I think that if you are working with data that doesn't need any semantic similarity, you don't need a vector database. So for example, let's say you're labeling cans and you want to say this can is lime flavored sparkling water. Okay, so now you have two kinds of key value pairs, right? Flavor, lime, water type, sparkling. And then you want to filter based off of, am I looking for sparkling water? Am I looking for still water? Am I looking for lime or grapefruit or apple or whatever? You want to say, that's like something where there's no need for a vector database. Like, just go to key value store. And also, it wouldn't really fit a vector database that well, because with text, you actually want the text to be, well, I guess it depends on the model that you use to generate your vector embeddings. But most models that we use to generate vector embeddings are trained on written text in the form of like sentences or paragraphs. And so if you have something like flavor, lime, comma, water, still, it won't understand that as well as if you said something like, this is a can of lime flavored sparkling water. So if you have your data in a different form than complete sentences, it's going to be, I don't think there's a lot of good models for finding the right embeddings. And then B, even if you do find the embeddings and you store them in a vector database, you're wasting your time. You could have just used a key value store.
Yeah, it's not the right tool for the task.
Right. It's not the right tool for that task. Yeah.
And so one other thing that I hear people talking about quite a bit is Elasticsearch. And Elasticsearch feels like it could be used for this, but not quite. Have you seen people talking about that? And like, how do you navigate, hey, should I be using Elasticsearch? Do I need to bring on a vector database? Can I just get away with what I've got?
Yeah, I've seen people talking about this as well, but to be honest, I don't have a lot of experience working with Elasticsearch, so I'm not entirely sure. Yeah, I can't really say.
All right, no worries then. So let's go into this idea of where you have been seeing generative AI apps. What are some common pitfalls that you have been seeing? So let's go into this idea of what different pitfalls you have been seeing in generative AI apps are.
Well, given the space where I work, most of the pitfalls I see in generative AI apps are just like data. And like I said, like I like most of them, what I just see is that they don't have the right data. Or what I've seen a lot on Stack Overflow recently has been people like saying things like, so this one's actually I've seen on Stack Overflow and Reddit is someone was like, hey, I have the CSV data and I vectorized and I put it in a vector database. And actually someone came to Milvus office hours with this question too. They were like, I have this data and I vectorized it and I put it in a vector database and it's not returning the right responses to me. What's up with that? What's going on? And then so we took a look. We took a look into their code with them and into the data as well. And what we found is that, for example, like I was saying earlier, your CSV data, it's not stored in full sentence like format. And so you have these problems like it's got a bunch of special characters in it, /r/n/t/u, these whatever. And then also there's a bunch of commas that just separate different independent clauses. And so when you have something like that, it's difficult to vectorize for machine learning models in general. And then it doesn't work well in a vector database or any kind of a database really. So one thing I see is people kind of like have dirty data, or they don't have the right data to insert. Or one thing that I think is interesting that I haven't seen a lot of people solving is really like, how do we make sure that our data in our vector database is continuously up to date as well? And like, you can build a pipeline for that. You can build batch insert for that. You can do event-based processing for that. But there's a bunch of kind of people who are just saying, what I see a lot of built in the LLM app space right now, generative AI apps, is like people who are just like, oh, like here's so I saw this one that was like ChatGPT for your PDF documents, where they throw a PDF into an OCR and then they vectorize that. And I've seen this multiple times. I don't know what they're doing underneath the hood. I don't know if they're getting the question space and having you question the question space, or if they're only storing the answer space. But I see a lot of things that are just like, here's how you query your own documents. Or for example, like AutoGPT, that one was like super popular, and I've met one person who's been like, oh, I was actually able to get this to do something like great, to do something useful for me. Someone said that they got it to build like a very simple like React site that like had a spinner on it. And I was like, oh, okay, that's cool. This is like the first story of anybody saying that they've done something with AutoGPT that's worked for them. I tried to get AutoGPT to do some research for me. And I was like, find me news from the last month of AI. And it went back to 2022. And I was like, this is not really what I need.
Little suspect.
Yeah, right.
Joke that I thought was hilarious, and I don't think anybody else laughed, but It was along the lines of, yeah, so I asked Auto GPT to cook me a carrot cake, and next thing, somebody from TaskRabbit is knocking on my door with the latest DVD from Space Jam, because like, what is going on?
Mixed up. Yeah. It says here, I'm going to do this.
There's a rabbit. Yeah, Bugs Bunny is in Space Jam, and then you've got Bugs Bunny likes carrots, and all. It just went way off the rails, and TaskRabbit and all that. So yeah, I think I've heard a lot of people echo that sentiment, but again, we digress. I didn't mean to derail you on this idea. I think the greater theme here is, and it just goes back to something that we say time in, time out on this podcast, is you got to be intimate with your data.
Yeah.
And you got to just go and know it. The really top performers, they can know that data so well and then get those insights from it because they're just so very familiar with what is going on in the data.
Yep. Knowing the data is definitely, I mean, I feel like anybody who's worked at ML for long enough kind of comes around. Everybody is, oh, these models, like when you first start, you're like, oh, these models are like so cool. We got to get like the right model. And then as you kind of get into it, you're like, oh, wait, what was the data that we trained this model with? And then you're like, oh, we didn't include anything about bananas. And so the model doesn't know anything about bananas and stuff like that. And it's interesting to kind of see that in the same way that it's kind of like how people are as well. You kind of see this like anthropomorph LLMs acting like people because they don't have like they don't have the data, and if you don't give them the data in the right form, it's just like people. If you don't give them the right data in the right form, they don't understand. And so it's very interesting to kind of like see that, and it's very interesting to see that as like a problem that we're kind of like facing right now.
100%. Yeah. So, dude, talk to me about Milvus. I know that you all have a ton of cool stuff going on, and there's Milvus, which is the open source project, right?
Right.
And then you have Zilliz, which is the beefy enterprise version, or is it like a managed Milvus? And then there's also Milvus Lite. And I know you all I think somebody, was it Frank? He presented at an MLOps community meetup in San Francisco, and it was all about GPTCash. So y'all are doing a ton of stuff. And then there's Zilliz Cloud too, right? There's a ton going on there. Break it all down for me and what you're seeing people using each one for.
Yeah, so I mostly use Milvus Lite. So there's Milvus, which is the open source vector database. And the great thing about, I think the really, really cool thing about Milvus for me is that it operates really well at scale. And when I say at scale, I mean like if you're working with 500 million vectors, kind of like scale.
Yeah.
And
there's some huge players that are using Milvus too. I know that I've seen like who uses Milvus, and it's that kind of scale.
Yeah, like Walmart and eBay, and they've got huge amounts of data. And I think that one of the things that when they first showed me the architecture diagram for Milvus, it looked pretty complicated, and it kind of is. There's 3 different kinds of like nodes that you spin up. There's a query node, a data node, an index node, and they all handle different things. And the query node handles how you query the data. The data handles actually what's going on with the data. And then in S3 or whatever persistent storage you use, there's all these like segments. So Milvus has these things called segments, and they grow up to 512 megabytes. And then once they're at 512 megabytes, they're sealed off. They're not touched anymore. They're just stored in persistent memory. And I think one of the reasons why Milvus works so well at scale is because of these segments. And it's really interesting to kind of like see how it works. Is let's say you have 1 terabyte of data. You don't want to re-index all of your data every time you add something to it, right? And one of the nice things, and also if you search 1 terabyte of data, that's just the amount of calculations you're going to have to perform is really high. So when you have that split into 512 megabyte segments, what happens is actually we parallelize each search for the segments so that it's actually possible to basically have, you're basically getting like you get much faster queries on large amounts of data. And it kind of, as it scales, your performance gets better and better relative to having single block chunks of data. So I think that's one thing that's really cool about it. This itself is usually run if you are running Milvus in like an enterprise, you're probably going to be running it on some sort of server, some sort of sets of servers that you can kind of like horizontally and vertically scale. And so if you want to run it locally, usually people use like Helm or Docker Compose, something like that. But the nice thing about Milvus Lite, and this is what I think is actually really cool, is it kind of like does this job of democratizing vector databases by making it more accessible. And so I wrote a piece recently about vector databases and how we're democratizing vector databases, and like the three like pillars that I have for that is like you provide like educational material that actually teaches people about what are vectors, what are vector indexes, what is the importance of using the right vectors and stuff like that. And then you have another pillar of making it accessible, because vector databases used to be, well, they're pretty complex in general. And so they used to be things that were pretty much available only to large players, like enterprise people. And now with things like Milvus Lite, you can run it directly in your notebook. You don't even have to be like a software dev. You don't have to understand like Docker or like Kubernetes or anything like that. You don't even have to know what an image is. You can just say pip install Milvus, default server.start, and you've got a vector notebook. You've got a vector database right in your notebook. And so now like data scientists, data analysts, people who could actually be using vector databases now have access to this, right? So I think that's cool. And then the last thing is obviously like the evangelism aspect, where you just go and you like tell people like, hey, this is cool technology, you should go check it out, right? But so yeah, I think that, you know, the Milvus Lite thing is really cool. I write a lot of Jupyter notebooks. I use a lot of just, it's easy to kind of like get these mini projects up and running, like Llama Index or like Lane Chain or anything else like that you can run in your vector notebook, and then you can, in your Jupyter notebook, and you can throw it on Colab, and it's like easily accessible to the public. So I work a lot with Milvus Lite. Initially, when I first onboarded, I worked with Milvus, like the standalone Milvus on a server version, which is fine. You have Docker and then you spin it up. But Milvus Lite is just really easy to use, and it's just really nice to have. And then Zilliz Cloud recently has released this like free feature where you now have free Zilliz Cloud up to 500,000, I think, vectors. And it's kind of like managed Milvus. Like you don't have to worry about scaling. You don't have to worry about hosting it on whatever host you're using, EC2, or you don't have to worry about spinning up and spinning down pods and stuff like that. So that's kind of what Zilliz is. That's what Zilliz Cloud is. GPTCash was like a project that we built that actually came from OSS Chat, which is the one that allows you to talk with the open source software. GPTCash was the caching layer for that. That was like, oh, someone's asking a lot about the same questions about PyTorch. Like people keep asking about Torch Vision, or people keep asking about Torch Audio. Now let's just cache some of this as well, so we don't have to ping about that. So GPTCash was kind of like that thing that was just like, hey, we're caching out a bunch of queries, like your FAQ, and you can save a bunch of money doing this, and here's how you do it. So yeah, that's pretty much like what Milvus and Zilliz have been up to. I'm really excited to see like a bunch of like new releases on Zilliz Cloud as well. People in the Milvus Slack ask me for things like, oh, is there dynamic indexing, like, or dynamic schemas? Can we change up things? And it's like, now, like you can just throw in like a JSON as your schema, and it'll accept that. You don't have to go and create your own. Like right now there's like a field schema, collection schema, and then like collection, and you have to put the field schemas into the collection schemas into the collections, and then it's like, oh, actually you don't have to do that anymore. And then there's like role-based access control, which people have been pinging me about on Milvus at least like 3 times or 4 times in the last couple weeks.
Everyone loves that, especially once you start to get into actual enterprise use cases. That's like a go, no-go type thing.
Yeah, we had someone who like literally came to us and was like, we've decided to go with Milvus because you guys are the first one to implement, or Zilliz because you guys are the first one to implement role-based access controls. And I was like, oh, very interesting. This is like not something that, you know, as like someone who doesn't necessarily have to work with enterprise data all the time, this is like an interesting like point.
Yeah, it's you got that SOC 2 compliance also?
I don't know. I think so. I don't know. But this is like just something that people came up to me and they were talking to me about in the Slack, and I was like, huh, okay, that's cool. Yeah. That's interesting. It's not something that I would have directly related or thought about.
Yeah, it's huge for some companies. I mean, it's a showstopper if you don't have that. Because
yeah. I remember when I was at Amazon, like the whole IAM policy was just, there was just a lot. You had to do a lot with the whole IAM thing. So
yeah, Yeah, that data access, man, that's a whole another beast in this. And I've heard horror stories too about how somebody got a job and then 6 months later they still didn't have access to the data that they were supposed to be working on. And it
Yeah,
was
that's
like,
yeah, I mean, that's just, yeah, it's terrible practice. It's also really relatable. Like I've worked at places where it's just, we want you to build this thing that requires you to train it on the data. And then I was like, okay, where's the data? Well, software devs don't have access to the production data. And I was like, well, what do you, can I get access? What do you want me to do? I'm not really sure. So yeah, I see that. That's like a thing at like mid-sized companies, like big companies. It's kind of weird. That's more of I feel like that's more of like a cultural, like work culture, like company culture kind of thing than anything else. Though I'm not really sure like how we could go about fixing these kinds of things.
Yeah, there's definitely people trying. I mean, I think that's what the whole data mesh crew is yelling about and talking how, oh, you got to own your data products and treat your data like it's a product, and you service the producers and the consumers, all that. So the producers service the consumers or whatever. That's my limited understanding of it just from talking to the different evangelists in the data mesh area. But I do know that there's some pain around that. And the bigger the company is, the worse it is. So dude, just a quick side note on GPTCash. What is this? Is it something that you can just slap on, or do I need to be running Milvus with it?
I think you just slap it on. I mean, it uses Milvus.
Okay. In the background.
Use Zilliz.
Okay.
But yeah, you would need, if you're going to run it standalone, you would need like a standalone server to ping.
Okay. Cool. Cool. Yeah. So this is all super cool stuff, man. And I'm wondering, like, anything else you want to mention before we jump? What's new in your world that we didn't get to talk about?
I just want to say, like, we're seeing a lot. We're in another like AI renaissance, for lack of better words. And I'm very excited to be part of it. I'm very excited to see more people get access to this kind of stuff. I'm hoping that we are able to provide like the educational material that people need to get started with this. And yeah, that's pretty much it. I'm pretty happy about this. On like a totally unrelated note, very happy to have the MLOps Seattle community getting started as well.
Yeah, we got to give a shout out to the Seattle community. You all did a meetup a week ago, I think, and yeah, it's growing and it's picking up steam, I would say. So I am very happy to see that happening too, and you're leading the charge on that one.
Yeah. I'm very interested. I love the community stuff. I love getting my hands into the technical stuff and building stuff, but I also love just seeing people come together and talk about things they're interested in, especially when it's AI. And I've been a nerd about this for a long time now, so I'm very happy to see other people talking about it.
Yes, awesome. So also, you mentioned that you're doing office hours, right?
Yes.
In the Milvus community. When is that, and what's the deal there?
Oh yeah, so we have these office hours with me and Philip. They're every Tuesday at 1:30 p.m. Pacific time. The questions are primarily being answered by Philip, to be honest. I'm just there to kind of like facilitate and answer like some basic stuff. But a lot of the times people will ask questions that are much more like, how do you use Milvus at an enterprise scale? And then Philip has a lot more experience than I do with that. And so he'll answer, oh, this is probably blah, blah, blah. This is probably blah, blah, blah. And you'll see kind of like, we see a few people come every week, usually 3 or 4 usually.
Nice.
Yeah, usually about 3 or 4 people. I don't think I've seen more than like 7.
Awesome.
Yeah.
So they get some quality time with you all to answer all of their questions, their heart's desire. We'll leave a link to those office hours in the show notes in case anyone wants to drop by and chat with you. And I think that's it for today, man. Thanks for coming on here and talking with me.
Okay, awesome. Sounds good, Demetrius. It's great to chat.
This is Skylar. I lead machine learning at Health Rhythms. If you want to stay on top of everything happening in MLOps, subscribe to this podcast now. 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 Now.